All right, imagine this. A football field, the crowd is roaring and a player is about to kick the ball. The anticipation is palpable, the energy electric. Everyone's eyes are glued to the ball, waiting for that moment of impact. What happens when that ball is kicked into the air? It's not just a simple arc, there's a lot more going on than meets the eye. A powerful kick sends the football into motion. The force from the player's foot transfers to the ball, propelling it forward with incredible speed and power. Now, here's where the fun part begins. The ball is now a projectile, and its journey through the air is influenced by several forces. According to Newton's first law of motion, the ball would just keep going straight forever if there were no other forces acting on it. This law states that an object in motion stays in motion unless acted upon by an external force. But of course there are. First, let's talk gravity. Gravity is the force that pulls objects towards the center of the Earth. Gravity pulls the ball down towards the ground. No matter how high or far the ball goes, gravity is always working to bring it back down. It's that invisible force that keeps us all anchored to the Earth. Without gravity, we'd all be floating around aimlessly. Next up is air resistance. As the ball moves through the air, it collides with air molecules, creating a force that opposes its motion. This is the force that works against the ball's motion, slowing it down as it flies through the air. The faster the ball moves, the greater the air resistance it encounters. But wait, there's more. Have you ever noticed how a spinning football curves in the air? This phenomenon is not just a random occurrence. This is thanks to something called the Magnus Effect. The Magnus Effect is a fascinating principle of physics that explains how the spin of an object affects its trajectory. When the ball spins, it creates different air pressures on each side, causing it to curve. The side of the ball spinning in the direction of the motion experiences lower pressure, while the opposite side experiences higher pressure. It's like magic, but it's all physics. The Magnus Effect can make the ball curve dramatically, adding an element of unpredictability to its flight. So, what goes up must come down. This is a fundamental principle of physics. Gravity wins in the end and brings the ball back down to the field. No matter how high the ball goes, it will always return to the ground. The whole journey of the football after being kicked is a beautiful dance of forces. Newton's laws, air resistance, gravity, and the Magnus Effect all playing their part. Each force contributes to the ball's unique path through the air, and there you have it. The next time you see a football soaring through the air, you'll know the intricate dance of physics that makes it all possible. The physics behind a kicked football's flight is truly fascinating. It's a perfect example of how science is at work in our everyday lives. The next time you're watching a game, you'll know exactly what's happening when that ball soars through the air. Pretty cool, right? Thanks for watching. Remember, every kick, every spin, every curve is a testament to the wonders of physics. Don't forget to like and subscribe for more fascinating science breakdowns. Stay curious and keep exploring the amazing world of physics.